Alright, so this is 6-1. Before we do the actual notes, we're going to fill out this kind of like a little cheat sheet. First thing we're going to do is we're going to fill in the different kind of shapes that we're going to be talking about. So the first one is a triangle. Then we have a quadrilateral. Pentagon. Hexagon. Heptagon. Octagon. And then we have an n-gon. So an n-gon can be after however many sides you have. If it's a big number like 20, 23, 25, 50, whatever, you would call it like a 50 gon, 48 gon. So when we go back up here, triangle has 3 sides, quadrilateral has 4 sides, pentagon's 5, hexagon 6, hepta is 7, and octa is 8. And then it says number of triangles. So what I'm going to do, and I'm going to move back up here, and you get this on the back side of your paper, is I'm going to show you what they mean by this. So I'm going to draw a triangle here, and it's not going to be the best, but it's a triangle. And what I want you to do is I want you to make little dots on your vertices. And then with a highlighter or a different color, just go from a vertex to a vertex, and then you're starting from that same vertex. So I went to one, then vertex to vertex, there's my other. And if you notice, I connected like all my dots from that one vertex, and none of those lines went through the triangle. So if you look at here, the number of triangles I have in this picture is just 1. And it'll make more sense when I go through these here in a second. So we just have 1 triangle. Quadrilateral has 4 sides. Doesn't matter what kind of quadrilateral. So again, I'm going to put circles on my vertices. Oops, I didn't need that. And then with my highlighter, I'm going to go from a vertex. You just pick one, and you're going to connect all the vertices to that one point that you picked. So there's 1 line, there's 2, there's 3. So if you look, I have 3 lines, and that actually splits this this quadrilateral into 2 triangles. So if you see here, here's 1 triangle, and here's 2 triangles. So for this one, a quadrilateral has 2 triangles. Okay, next one's a pentagon. Let's see. So there's 5 sides. And it's okay if your picture is as horrible as mine. So what you do is you pick 1 vertex, and you just connect all your vertices to that one that you pick. So there's 1, 2, 3, 4. And then if you look, you try to figure out how many triangles did we create. So here is 1. Here's 2, and here is 3. So for this one, it's 3 triangles. And I think so far, you can tell that we have a pattern here. And if not, you can draw hexagon, heptagon, octagon, and keep doing the same process that we're doing. But if you look, from the number of sides to the number of triangles, there's a relationship. And how do you go from 3 to 1, 4 to 2, 5 to 3? Well, you're just subtracting 2. So for 6, when I subtract 2, 6 minus 2 is 4, 7 minus 2 is 5, 8 minus 2 is 6. So when you get here and you have n amount of sides, it's just n minus 2. Okay. To figure out the sum of the interior angles, we're going to use that column. So here, you have 1 triangle. How many degrees are in 1 triangle? 180. So how many degrees do I have total on the inside of that triangle? 180 degrees. For a quadrilateral, you had 2 triangles. How many degrees are in each triangle? 180. So how many degrees do we have total? 360. And so I don't waste time going back and forth in colors. I know that how many triangles I have. And I know that in one triangle there's 180 degrees. So all I have to do is just multiply it by how many triangles that figure has. So here this would be 540. For this one, 180 degrees. For 180 is 720. 5 times 180 is 900. 6 times 180 is 1080. And then here when you have n minus 2, you'll just multiply that by 180 degrees. So that's the sum of the interior angle. So that's how many angle, or when I add up every single individual angle on the inside of that shape, that's how many I have total. So now we have to figure out how many we have for just one. So if I know the whole amount, so in this case, for this first one, I have 180 degrees for the whole amount. If I just want to figure out what one is, I have to divide it by how many there is. So in a triangle, how many angles do I have in a triangle? I have 3. So 180 divided by 3 would give me 60. So each one of those angles in there will be 60 degrees. For a quadrilateral, there's 360 degrees total. But whenever I look at how many angles I have on the inside, there's 4. 360 divided by 4 gives me 90. And same thing, 540 degrees for a pentagon. There's 5 angles, so that gives me 108. 720 divided by 6 for a hexagon, 120 degrees. And then we have 900 divided by 7 for a heptagon. This is the only one that comes out kind of funny. 128.57 degrees. 1080 divided by 8 for octagon is 135 degrees. And then the last thing that we have here is n minus 2 times that by the 180 degrees, because that's the whole thing. All we did is we took that number and we divide it by n, however many sides you have. Because if you look back over here at the column of the number of sides, that's the same thing as how many angles you have in that polygon. Okay, now we're going to look though at the exterior. Okay, so let's go back over here. Triangle has 3 sides. Pentagon has 5 sides. If it's n, that is a nonagon. And again, we have n for n-gon. And n can be any number like 13, 14, 15, so on. Okay, so the measure of one interior angle of a regular polygon, we already have that information. That's the last column that we did. So for a triangle, one angle inside a regular triangle will be 60 degrees. One angle inside of a regular pentagon is 108. One angle inside of a regular nonagon is 140 degrees. And then for n, we just use that formula, n minus 2 times 180 divided by n. And you will need to know these formulas. Okay, so now to figure out how to get my exterior angle. So I'm going to use the simplest shape that we have here, and that's going to be a triangle. Okay, so if this is 60 degrees, and I'm trying to figure out what my exterior angle is right here, what do I know about these two angles? What kind of relationship do they have? Well, they're a linear pair. They lie on the same line. Or you can look and say, hey, that's a straight angle. How many degrees are in that? 180. So if both of these have to add up to 180 degrees, if that one is 60, what does the other one have to be? Well, the other one in here is going to have to be 120 degrees. So my exterior angle will be 120 degrees. So what's the only one thing I did to figure that out? I did 180 minus that interior angle. So 180 minus 108 would give me 72. 180 minus 140 would give me 40. So here, all I'm doing is 180 degrees minus that formula that we have. And minus 2 times 180 over n. Okay, so now it's asking for the exterior angle sum. So let's just look at this, and it works every single time. So how many exterior angles do we have? We have 3. So I have 120 degrees. I have 3 exterior angles, so that will give me a total of 360 degrees. Okay, this one for the pentagon, one exterior angle is 72 degrees. I have 5 exterior angles, and that comes out to 360 degrees. And then this last one, that's 40. That is for a nonagon, so that's 9. So we have 40 degrees. I have 9 of those, and so that will give me 360 degrees. So anytime you talk about the exterior angle sum, and it's only with the sum, it will always, always, always be for regular polygons 360 degrees. So that's like a little cheat sheet. It also kind of shows you how we come up with these formulas and why they work. So now we're going to get to the notes, do a couple examples, and then your homework is on Alex. So starting here with the first one, polygon interior angle sum. So first we have a triangle. There's 3 sides. That's why we call it a triangle. But if you notice, when I do my vertices, none of the vertices will cut through my triangles. So I have 1 triangle here. Quadrilateral, that's going to be 4. And again, just so you have this on your paper, whenever I match up my vertices, we cut through 1 time. So that leaves me with 2 triangles. Here for a pentagon, since we didn't see this last time, and I'll zoom in on this. Okay, so for the pentagon again, when you draw, connect that 1 vertice to the rest, you can see how it splits up. So we have 1, 2, 3 triangles. And again, same thing. Connect to your vertice to the other vertices, and you have 1, 2, 3, 4 here. And last one, connect your vertices. You can have 1, 2, 3, 4, 5. So to find the angle sum, all you have to do is 180 n minus 2. Or you could write n minus 2 times 180 like on the other paper, it doesn't matter. And then to find one of them, all you have to do is just divide that entire thing by n. So this is going to be 180 n minus 2. All of that is divided by n. Okay, so a couple examples. A convex polygon has 13 sides, so we know n is equal to 13. Find the sum of the measures of the interior angles. So I'm going to highlight that word sum of the measure of the interior angles, because you're going to see find just one interior, find the sum of the interior, find just one exterior, find the sum of the exterior, so you have to be careful in what they're asking for. So when you have this sum of the measures of the interior, my formula is going to be 180 n minus 2. So I'm going to plug that in, 180, 13 minus 2. And what we end up getting is 1,980 degrees. Okay, example number 2. The sum measure of interior angle of a regular polygon is 120. Find the number of sides. So this one, it actually gives you the measure of an interior angle, which is just one of them, and it wants you to find the number of sides. So since they're giving me one angle, I have 180. n minus 2 divided by n is equal to 120 degrees. So we're going to have to do a little bit of algebra here. So the first thing you have to do to get n by itself is multiply both sides by n. So we will have 180 n minus 2 is equal to 120 n. I'm going to distribute the 180 degrees. And when I distribute, I get 180 n minus 360 is equal to 120n. Subtract 180n from both sides. So negative 360 is equal to negative 60n. And when you divide both sides by negative 60, you will get n is equal to 6. So that would be a hexagon. All right. And then the last one like this, find the value of x and the measure of each interior angle. So first thing that I would do is I would count how many sides you have here. So you have 1, 2, 3, 4. You have 5 sides. So since n is equal to 5, I know, so 180, not n, 5 minus 2, so 180 times 3 will give me 540 degrees. So I know all these angles in here have to add up. So 4x plus 5, 5x minus 5, 6x, oh, yep, nope, that's right, 6x plus 10, 4x plus 10, 7x, and when I add all those up, I will get 26x plus 20, and I know that has to equal to 540. So 26x has to equal to 20, so x will just give me 20. Now that's not the answer, well that's part of it, but it's asking you to find the measures of each interior angle. So I have to find the measure of angle A, measure of angle B, measure of angle C, measure of angle D, and the measure of angle E. And all you do is you just plug in 20 for x. So when you do this, you get 90, 130, 95, 85, and 140. And the way you can tell whether you did this right or wrong is you can add all those up and make sure it comes out to 540 degrees. All right, back side. This is the easy side because it's talking about the exterior angle sum theorem. So the exterior angle sum theorem, it will always be 360 degrees. And if you want to find one, you just do 360 divided by n. So first one says find the sum of the measures of the exterior angles, one at each vertex of the convex 27gon. So first to find the sum, I know the sum will always be 360 degrees. And then to find each, you do 360 divided by 27. So you'll get 13.33 degrees for each exterior angle. So both these would be your answer. Last one, find the measure of each exterior angle of a regular hexagon. So n is equal to 6 because it's a hexagon, and it wants me to find the measure of each. So again, if you want to highlight that each exterior angle, then all you have to do is 360 divided by 6, and so we get 60 degrees. And that is it. That is 6-1.